Unit 3, Lesson 3, Solving Quadratic Equations. So to solve a quadratic equation means to figure out what the value of x is. And we do that by factoring. So we've learned and reviewed a bunch of different factoring methods. And when all of those factoring methods don't work, you revert to the quadratic formula. Okay, and this quadratic formula is listed here. You should remember that from grade 10. So let's go ahead and solve these two equations. So in the first one, let's first check to see if any of our factoring methods from before work to factor this. Okay, because they're usually easier than using the quadratic formula. So a is equal to 1. So let's try our magic numbers or decomposition method. So we need two numbers whose product is equal to -12, and the same two numbers have a sum of -1. Okay, and this works out because the magic numbers are going to be -4 and 3. And now because a is equal to 1, those magic numbers are the factors. So now to find the actual values of x, we take each of the factors and set them to 0. And then we solve for x. So the first value of x is 4, and the second value of x is -3. So that also represents the zeros of this quadratic function. Okay, part B, we have terms on both sides of the equal sign. So let's get them all into the same side and then combine like terms. Now you're going to notice that none of your initial factoring methods work for this, so we need to revert to the quadratic formula. So it's pictured right here, and remember that a represents the coefficient of x squared, b is the coefficient of x, and c is your term without a variable. Let's go ahead and plug those values into our quadratic formula. Okay, so remember, this yields two possible answers. The first answer is going to be 5 plus root 73 divided by 6, and the second answer is going to be 5 minus root 73 divided by 6. Okay, so plug that into your calculator and see what you get. Okay, and we can use decimals here because the question doesn't ask for exact values. If it asked for exact values, we would have to simplify our radicals. So in example 2, they say determine the exact solutions of f at x. So in here, our final answers cannot have decimals. So you want to leave the radical signs. Okay, so you're going to realize that this is not factorable by our initial methods, so we need to use the quadratic formula. Okay, so because we have to use exact solutions, let's simplify this radical. So root 32 can be divided into root 16 and root 2. And 16 is a perfect square, so that'll be easy to simplify. We can reduce our fractions, right? 4 over 8 is the same as 1 over 2, and 4 root 2 over 8 is the same as root 2 over 4, is the same as root 2 over 2. Okay, now we have two answers here. So the first answer is going to be 1 plus root 2 over 2. And the second answer is going to be 1 minus root 2 over 2 over 2. Okay, and those are exact values. We don't have any like terms that we can simplify, and we don't have any radicals that we can break down. Our last example is a word problem. So a water balloon is catapulted into the air from the top of a building. The height h in meters of the balloon after t seconds is given by the function h at t equals negative 5t squared plus 30t plus 10. State the domain and range of this function. So to state the domain and range, we need to know which direction the quadratic opens and the vertex. So let's start with the domain because it's a quadratic. We know it encompasses all x values. Now the range is a little bit more difficult, okay? So first, we know that the quadratic opens down because our a value is negative, but we don't know what the vertex is because our quadratic is written in standard form. So if you remember, to go from standard into vertex form, we are able to do that by completing the square. So let's review completing a square. So we start with our original function in standard form. You would have learned this in grade 10. So the first thing that you do is you factor the a value out of the first two terms. So our a value is negative 5. So let's factor it out of the first two terms. Okay, now what we do to complete the square is we essentially want to turn this set of brackets into a perfect square trinomial. And to do that, we are going to add and subtract the b value divided by 2 squared into that set of brackets. So you always take the b value, divide it by 2 and square it, and whatever that number is, you add and subtract it inside those brackets. So our b value is negative 6, and negative 6 divided by 2 is negative 3, and then negative 3 squared is 9. So 9 is the number we're going to plug into those brackets. Okay, but we're going to add 9 and subtract 9 because it's not really changing the problem. You're essentially adding 0 just in two pieces. Okay, because if we just added in plus 9, that would change the entire function. Okay, now we're going to remove the minus 9 from inside of the brackets by multiplying it by this coefficient. We're essentially doing the distributive property. Okay, so when that negative 9 goes outside of the brackets, we have to multiply it by that negative 5. So we get plus 45. Okay, now let's simplify this. Okay, we need to now factor this, and you're going to notice that this is a perfect square trinomial, so we can use that shortcut method. And this will always be a perfect square trinomial, right? We set it up so that it would be a perfect square trinomial by doing what we did in the steps before. So to factor a perfect square trinomial, you set up your brackets, you take the square root of the first term and the square root of the third term, then you take the sine of the middle term and square the whole thing. And look at that, that is now in vertex form. So we can now identify our vertex. Our vertex is at 3 and 55. Okay, so if we have a quadratic whose vertex is at 3 and 55 and it opens down, we know that it only encompasses y values less than or equal to 55. And then because this is an application problem, right, you're throwing a water balloon in the air, there's another added restriction. Okay, we also have a boundary line here because that water balloon is never going to go below the ground, right? It just lands on the ground and stops. So this problem only encompasses y values between 55 and 0. So that's our restriction. Part B, when will this balloon reach a height of 35 meters? So we're going to plug in 35 for h at t. And then we're going to solve for t. Okay, so let's get all our terms to the one side. So let's bring that 35 to the other side. Now let's simplify. Now we're going to try and factor this. So we have to use the quadratic formula. Okay, so we have two answers. So therefore, the balloon is at 35 meters after 1 and 5 seconds. And that makes sense, right? It's going to happen twice. It's going to happen once on the way up and once on the way down.